This week we're looking at problem-solving skills. We are going to look at some theory, but it's actually theory that you've already covered. It's just a good opportunity to go back into gravitational and circular motion, partly because it does involve some much more in-depth and complicated problems really to get your teeth into, but around a topic that you can kind of study as a whole. But we are going to expand out into more broad problem solving, again, all based on ideas that you've met before. So there'll be no new theories being learned this week. It's all really about practice. So the key is, don't really skip over things because you think, oh, I don't need to do this because it's not going to lead into an assessment or anything like that. The point of this is developing your problem solving skills, and you'll need those as you go forwards into future web works and obviously potentially for exams and assessments and all sorts of things later on. So it develops these basic skills, but there's no shortcut. Really, the way you get better at solving problems is by doing problems. So there's a few things to look at this week. Firstly, there's one or two just little videos. I just called them pit stop videos because they're all no more than sort of 5 or 10 minutes long. So have a little look at some of those. Again, one of them is just about working algebraically, which is something we keep talking to you about. But again, it's just another little example for you to run through to see how that process works. And it really is something I'd like you to work on as you're doing your problems this week. The other things involve just looking at how to approach slightly more difficult problems, so problem-solving methods, and then another short video about using the idea of ratios. So for some of the problems that you've met, for example, ideal gases, where things change, or you're comparing two situations involving the same equation. So this can be anything from like Kepler's law, as I say, ideal gases. Pretty much any part of physics can bring this style of question in, but some do lend themselves to it more than others. So there's, again, a little short video to run through that. But the bulk of what you want to spend your time doing this week is working on 2 sets of questions. So we return to chapter 6. Again, you've studied this before, but I have put the link in just so that you can get back to the information. You might want to have a quick read through the summary page before you crack on with the questions. There's a set of questions on gravity and a set of answers. So do have a go at those. They are more tricky. So don't be afraid to sit with the questions and the answers, but have a go and get as far as you can with the problems. You get better at problem solving by doing problems. You will also get stuck a lot. So if you're completely stuck and you've tried everything you can think of, have a little look at the answers, but perhaps don't look at the full answer. Just have a look at the beginnings of the answer, see what route it went down, see what equation got used, and then go back and have another go. So keep plugging away at it. There's then a set of mixed problems. Now, these are probably the most important thing to work on this week. There's mixed questions. They come from all over the place, using all sorts of different theory, including gravity and elsewhere. There are then hints. So instead of you having to go to the answers to get a bit of help, if you're completely stuck, go and have a look at the hint sheet. And that way you've not got to avoid looking at the answer and pretending you've not seen it. You can look at the hints, but again, if you are completely stumped, go to the answers. I'd suggest, again, working through them in order, but there's no specific order necessarily to them. They probably get a bit tougher, or they do link together as you work through. So there's nothing new to learn. So what you would normally spend in hours learning new material, I want you to spend that time now as extra time doing problems. There's also no web works for this particular week. So this is purely about, there's no pressure, get some practice problems done. Learn those skills. You just get better by doing, basically. Okay, so let's just have a really quick run through some problem-solving skills. The only thing I want to say about this week before we do that is, as there is a little bit less to learn this week, you've got a few extra Labster simulations to do. So there's actually 4 week 6 Labsters. All of them are based around gravitation and Kepler's laws. So again, they will all kind of underpin what you're studying this week. Okay, don't forget that you've been working on your data task as well, so this is a good opportunity for you to ask for any help if you need assistance with the Excel document. Okay, so really quickly, some problem-solving skills, but I'll go into this in a little bit more detail in one of the other videos. So the first thing is, make sure you know what the question is asking. This seems obvious, but the number of people who try to solve a question, and then if we actually ask them, what are you trying to find? They're not really sure. They know it's a force or a distance, but they don't know what that force is or what that distance is. So make sure you're clear on the question before you get too stuck in. Get the initial information down, and 9 times out of 10, a sketch will help, even if it's not a mechanics problem. Also, a list of equations. If you sort of know where you've got to go with it, or you know there's only 2 or 3 equations you could use, then that's probably okay. But if you're completely stuck, get all of the possible equations written down. It might be that there's 20. But if they're written on the page in front of you, you've thought about them, you can see them. You can see the way through a little bit more clearly when it presents itself. Start somewhere. A lot of people sit and look at a problem. Because they don't know where to go, they don't make a start. All right, problem solving is very much like going through a maze. You've got to expect to hit a few dead ends, and you don't not go into a maze because you can't see the route all the way through to getting out. So you do have to just get in there. Don't be afraid to make some mistakes. The best bit of advice, as we've always said, is work algebraically, and again, see the little video about that. The simple reason being is, if you get somewhere and you hit a dead end, you don't have to go all the way back to square one, effectively, to begin again. But you can potentially take some of the equations that you've used and go in a different direction a lot more easily. You can also check for mistakes if you're working algebraically, and it's also a lot more ordered. It doesn't feel as natural, but that's just because it's not what you're used to, but it is a far better way of working. Good physics knowledge obviously underpins problem solving. If you're trying to solve a problem when you don't really understand the physics behind it, it's going to be a lot harder. This can be just as simple as, if you see some information, you should know immediately which equations you can use to work out the thing you want based on the information that you have. Equally, if you're familiar with the concepts, you might be able to apply those. So, for example, applying the idea that forces have to be balanced as soon as you realise that an object is moving at a uniform velocity. Start simple. This doesn't always work, but it can be a good place to start. So, for example, if you were doing something involving energy changes, you could just start with a really simple energy equation. And I mean like a word equation. So, start energy equals end energy. Clockwise moments equals anti-clockwise moments. Forces up equal forces down. Sometimes that can be a really good place to start. Or, something like F equals ma, start with a simple equation. You might not know the force, the mass, or the acceleration, but you can build things into that until you can link the thing that you want to the information that you have. Very often with more complicated equations or more complicated problems, there's multiple steps. So it isn't a case of applying one concept or one equation. You have to sort of feel your way through and make a few mistakes, which can mean working from both ends. It could be a case of, well, I can work these things out, given the information I've got, and I need to get here, so what equations do I know that relate to that? And eventually you'll see, oh, well, that equation gives me the acceleration, which is what I'm after, and from this I can work out a force, and from that I can work out a mass. So sometimes working the problem from both ends does help. Sometimes it can be an inconvenience and it can be difficult. Again, this comes with experience. It's not something you can just read about and be able to do. It's something you learn by doing multiple problems. The more of them you do, the easier it is to spot ways through these problems. Absolutely don't be afraid to get things wrong. It's problem solving. You're not going from question to answer. You're going from question to 3 things that don't give you an answer to 1 thing that almost did, and you realise you've made a mistake, and then you go back to one of the things you already tried, and lo and behold, it worked when you did a slightly different approach. And always do a little check. Sometimes it can be as simple as, does the number you get out make sense? If it's less obvious what the number is that you're dealing with, let's say you've no idea how many electron volts a proton should have doing a certain speed, so you're not sure if it makes sense. But you can at least check things like, is it positive, is it negative when it should be? You can follow the units through, make sure the units make sense. You can do a simplified version of the calculation just to get a ballpark figure. Should it be around about times 10 to the 6? And have you got something which is around about times 10 to the 6? There's always some check you can do on some level. Okay, that's really whistle-stop tour of solving more complex problems. But to be honest, the best bit of advice I can give you is go and do some. Do as many as you can and get plenty of practice in.